Let's calculate the determinant on the screen. As you can see, there are letters in it which can complicate things. One way to calculate the determinant would be to expand it directly, either using Saris or by row or column. However, as is usually advisable in these cases, we'll reason by applying the properties of determinants and make the tasks simpler. First, and this happens often in exercises, notice that the same elements appear in each row but in a different order. In this case, always adding all the rows or all the columns, we get a row or column whose elements are all the same, and that's useful. What we can do, for example, is add all the rows and then replace, say, the third row by the sum of the first plus the second plus the third row. Note that we're substituting a row for the sum of that row plus a linear combination of the rest, and as you know, from the properties of determinants, the result does not change. So we copy the first two rows, and instead of the third, we write the result of the sum of the three rows. A plus 2b plus a plus b plus a is 3a plus 3b. A plus 2b plus a plus b is 3a plus 3b. And a plus b plus a plus 2b is also 3a plus 3b. So now we have as the third row the factor 3a plus 3b multiplied by 1, 1, 1. Taking 3a plus 3b out of the determinant, we have 3a plus 3b times the determinant of the matrix. We copy the first and second row, and for the third we put 1, 1, 1. Now, we could go ahead and develop the determinant, but let's think a moment. Notice that if we subtract the first and second rows, the a's go away, which is interesting. So, now we'll replace, for example, the second row by -1 times the first row plus the second. This is what we're left with. Instead of 3a plus 3b, we take out a common factor of 3 and write 3 times a plus b. This is times the determinant. We copy the first and third row and replace the second row with the second row minus the first row. We have a plus b minus a plus 2b is minus b. A plus 2b minus a is 2b. And a minus a plus b is minus b. Just be careful with the signs. Now, we have a common factor in the elements of the second row, namely b. It comes out of the determinant, so we have 3 times a plus b times b, and now the determinant. We copy the first and third rows, and in the second row, after taking out b, we have -1, 2, -1. Notice that if we add the second and third rows, here and here, we get 0. So for the third row, we can substitute the second row plus the third. We have 3 times a plus b times b times the determinant. We copy the first and second row, and instead of the third row, we have the second add the third row. -1 plus 1 is 0, 2 plus 1 is 3, and -1 plus 1 is 0. Now we can easily develop the determinant by the third row. We copy 3 times a plus b times b. In the third row, we only have this non-null element. The determinant is 3, and for its adjoint, it's in the third row and second column, -1 raised to 2 plus 3. This is multiplied by the determinant that results from eliminating its row and column. And there it is. To finish off, -1 raised to 2 plus 3 is -1 raised to 5, which is -1, multiplied by this 3 and this 3 to give -9. This is times a plus b, b. Then we just have this determinant left. A plus 2b times -1 is minus a minus 2b. Now, -1 plus a plus b. We're left with -9 times a plus b times, well, the a minus plus a cancel, and -2b plus b is minus b. So we get 9 times a plus b, and b times b is b squared. And that's the result of the determinant we started with.